20 and 21 I'll do together here. Two sample test, two sample hypothesis testing. Let's see what we have. Again, if I go to my table here, I have the procedure for hypothesis testing. I'll show both methods again, no worries. So the first step for each of these is to state the hypotheses and identify the claim. Whoops, this is my calculator. Hypotheses are already stated. Null, the means are equal. Alternative, mean one, keep doing that. Mean 1 is less than mean 2. So this is left-tailed. Left-tailed. And we have the sample means, sample standard deviations. Notice we don't have the population standard deviations, t-test time. And 1 equals 15, and 2 equals 13. Degrees of freedom, smaller of the two, -1, so the degrees of freedom here are 12. The hint is first compute the value of the test statistic. So let's calculate t first. T equals, so we've got x1 bar minus x2 bar minus mean 1 minus population mean 2 divided by the square root of first standard deviation squared over n1 plus second standard deviation squared over n2. Substituting in 11 minus 9 minus means are equal, population means are equal 0 over the square root of 7 squared over 15 plus 5 squared. I'll just call those what they are for calculation's sake. 49 over 15 plus 25 over 13. So t equals 2 over something. Let's see what that something is. And I'll make sure to type everything in properly here. So I've got the square root of, in parentheses, 49 divided by 15 plus, in parentheses, 25 divided by 13, close parentheses. So that's 2 over 2.781. So that t value, let's divide. 2 divided by 2.78. I almost did it again. 81. 0.7192. Let's look at that to make sure I'm right. 0.7192. So that's the test statistic t. Okay, so that's our test statistic t. Now, depending on whichever approach I'm using, right, I can use the p-value method, or I can use the traditional method. Either way, I should get the same, I should come to the same conclusion, right? So at the 0.05 level, so the critical value, oh wait, I can go straight to the table here. 0.05 level, left-tailed, right? There's my table. Degrees of freedom are 12. Degrees of freedom are 12. 0.05 one-tailed, right? See that? Degrees of freedom are 12. 0.05. 1.782. 1.782. $1.782. So, but since we're left-tailed, we're talking about here, so this should be negative 1.782. Yes? And my t-value is definitely not in this region. My t-value is positive. Right? My t-value is definitely not in this region, so do not reject. H sub 0. That's my conclusion here. Now the p-value. Yes, the p-value. Okay, so again, we first have to calculate this t-value. T is 0.7192, and we're talking about the 0.05 level of alpha. And, well, actually, I don't think we show a p-value approach for these t-tests here, so I'm not even going to go there. Looking at number 21. Again, our null hypothesis, our alternative hypothesis, mean 1 less than mean 2. This is also left-tailed. Okay. Sample means, x bar 1 is 7, x bar 2 is 15. Sample standard deviations again. We're looking at another t-test. Sample sizes. So our degrees of freedom will be the smaller, 10 minus 1, which is 9. You can do this in the calculator too. I just didn't show. I showed it in the problem some problems ago. So you can utilize that same approach there. So let's take the hint and compute the test statistic. X bar 1 minus x bar 2 minus mu 1 minus mu 2 over the square root of s1 squared divided by n1 plus s2 squared divided by n2. Substituting 7 minus 15 minus 0 over the square root of 9 over 19 plus 36 over 10. So t equals negative 8 over, let's see, square root of parentheses 9 divided by 19, close parentheses, plus parentheses 36 divided by 10, close both, 2.0183. 2.0183. Negative 8 divided by that. Negative 8, oops. Clear that. Negative 8 divided by 2.0183. Negative 3.96. It's my t-value. That's my t-value. That's my t-value. Negative 3.96 is my rejection region there. 0.05 level, degrees of freedom are 9, left-tailed. Degrees of freedom are 9, 0.05 level, one tail, 1.833. Oh no, oh no, oh no, oh no, I said something crazy. This is not the critical value. This is the test value that we found here. So this is the value we're testing to see if it's in that interval there. That's my mistake. My mistake. So the t critical value. Let me see, did I make that mistake up here too? No, I did it right up here. The critical value was negative 1 point. Yeah, I did it right up there. Sorry, I made a mistake here. So the t critical value is the one that we're finding from the table, right? 9 degrees of freedom, 0.05 level, 9 degrees of freedom, 0.05 level, that's 1.833. Right, 0.05 for one tail, 1.833. And since this is left-tailed, that'll be negative 1.833. Okay, so this is 0.05 here. Yes. Now I'm going to test this value. The t-critical value is negative 1.833. I'm going to test negative 3.96. Negative 3.96 is definitely less than negative 1.833. It's in this critical region. It's in the rejection region. So, yes, we reject the null hypothesis here. My apologies. So here we reject the null hypothesis. Yes, we do.